All right, go ahead.
All right. Thank you very much for setting this up, and thank you for the introduction. I'm excited to be here. Obviously, as Afshin said, I've kind of lived this work for a long time, and I like helping students. So I put together a few slides to just talk about computer science as a major, what you need to do in college, or what does it mean to study computer science in college, and what does it mean to be a computer scientist. And I'll go through the slides, and we should have some time at the end if somebody if you have any specific questions, I'm more than happy to answer. So Afshin already talked about my background and kind of introduced me, so thank you for that. But now that the recording has started, I just want to say that I studied computer science. I actually started studying applied math and then transferred and changed my major to computer science later on. So I've been a math major, I've been a computer science major, and then I worked after I got my undergraduate degrees for about a couple of years, and then decided to go back to graduate school. So that's when I went and got a master's and PhD, and then I joined the faculty at Seattle University. I was a professor there for 15 years, and I was chair of the computer science department. So in that capacity, I helped a lot of high school students and their families that they would come for college visit. You hear about college visit, and you always think about you need to be taking your kids for college visits. I was on the other side of the table trying to answer questions that high school students and their families had when they came for a college visit for many years. And then as you heard last year, I left that job. I just wanted some change, and I started a position at Amazon, and I work for Alexa, which many of you might have in your houses. And I'm going to turn it off, mine off, so it doesn't start talking. And my team's job is to make sure that Alexa speaks appropriate things. So if you ask a question that is inappropriate, she doesn't answer you inappropriately. And if you ask just a normal question, she doesn't answer you inappropriately. And that's pretty a very ambiguous and interesting and fascinating field to be working in. And more, if you have questions on that, I can answer at the end. So that's kind of my background. In the talk tonight, I'm going to tell you a little bit about computer science, but more generally, I want to kind of broaden that conversation and talk about field of computing a little bit, because I think when a lot of times when people hear computer science and talk about computer science, they're just thinking about software development or software engineering positions. So I want to kind of extend that and describe what that means. Hopefully you are going to get, at the end of this, you're going to have some ideas to help you decide if computer science is the right degree for you. And maybe you can also learn about different kind of career opportunities that are available if you get a degree in computer science or in the field of computing, and then talk about the different jobs that are available. The first thing I hear when I talk to high school students, or when I talk to friends who have high school students as kids, you always hear that computer science is the most popular college major, and that's very true. I can just tell you that from my own experiences, over the last 7 or 8 years that I was at the university, the department grew by about 500%. So there's definitely a lot of interest. There is a lot of job opportunities that are available, and the kind of demand for computer science degrees continues to grow. So that contributes to the fact that it's a popular major, and the career opportunities that are available with a computer science degree are plentiful, and they pay really well. So that's always a reason that people also choose computer science as a major. But obviously that's not sufficient. That's not enough. You have to like what you are doing. So hopefully, again, by the end of this talk, you will get a little bit of a perspective of different kinds of things that you can do with a computer science degree. The other common thing that I hear when people talk about computer science or think about computer science as a major is that my parents want me to study computer science, and that's very common. And it's not always a bad thing. It's not necessarily a bad thing. So parents have different reasons that they want their kids to go to computer science. Some of the reasons are the reasons that I just mentioned, but it's also when you choose a college major, there are a lot of factors that you want to consider, and one of them is the opportunities that are available. So that might be contributing to why some of your parents might be interested in you studying computer science. Again, more on this in a bit. Another thing I hear a lot is that I don't know if I like computer programming, coding, or computer science, and you hear any of those kind of terminology being used, and we'll talk about that a little bit too. I personally am of the belief that we tend to like things that we are good at more. So once you learn and kind of get excited to learn enough to know what you are doing, then you start to like it more. That's something to consider. Having said that, I want to talk about what programming is and what coding is and what computer science is. To me, they are not the same things. Sometimes you hear people saying, I don't want to code all day, and we'll talk about that and see if you get a job in computer science, do you have to code all day, or can you do other things in the field? What are the different jobs that are in the tech industry? And finally, I sometimes hear that I don't want to be a nerd, and you don't have to be a nerd to study computer science, and you don't have to be a nerd to be a computer scientist. So I have plenty of people around me who are not nerds, or I've had plenty of students who are not nerdy, and they were fantastic computer scientists. So those are just some things to keep in mind. I want to highlight some things in the next few slides that you already know. I just kind of want to draw attention to what computing has done to our lives. Technology is really intertwined in everything that we do every day. And if you think about it in your classes, in your classroom, even if you're a high school student today, compare your classroom today with your elementary school classrooms. And the kind of technology that exists in classrooms today is pretty fascinating. You submit your assignments on Canvas, you watch YouTube videos to learn, you connect with Zoom to listen to the webinar, you use Microsoft Office productivity all the time. Google is a verb now. You use a browser to access everything, and a lot of this, when you kind of zoom into this and understand what that entails, basically there is a computer or a device or a phone or a tablet or something that you use to connect to the internet, which is somewhere out there. You can't really see it. It's in the cloud. And then somewhere the data is stored somewhere. That's kind of the gist of what a lot of the applications that we use today. So that, just keep that in your mind as we go through this. Computing is also exists everywhere in entertainment. I mean, it used to be that you would go to a movie theater to watch a movie. Now you have a smart TV, and you have a lot of different things in there. One of the things, the data points I've used in some of my classes before was that a typical TV 20 years ago had, I don't know, I think it was something like 2 kilobytes of program in it. And the typical TV today has gigabytes of programs in it. So the smart TVs, the entire application of a smart TV is built on computing at its core. You have Netflix, and you have all kinds of other entertainment. If you are into games or virtual reality kind of experiences, obviously those are very popular and interesting and cutting edge in many ways. Computing exists in communications. Without the pandemic, would have been completely a different experience if we didn't have computing and the computing resources that we have today to get through the last couple of years. So that there's nothing, you all know that firsthand as students who were at home studying last year. In our houses, computing and computer science, essentially application exists in everything from a smart fridge to your thermometer that you can control with your phone, to a smart vacuum cleaner that lends a map of your house as it vacuums the house and knows where to go to work, from your security system and the Ring cameras to smart locks that you might be using instead of using a regular traditional key and lock to lock your house. So our homes, all of our homes are smart, different degree of smartness, but they're all smart these days. Computing also has kind of emerged in the field of healthcare, and this was one of those areas where there was a lot of resistance. There is, doctors don't consider themselves to be really good with technology, so it was difficult to sort of for the field of computing to arrive in medicine. But from robotic surgery to all kinds of medical imaging that you can imagine, the term that you hear a lot these days are machine learning and AI, and I talk about those briefly. But AI, or artificial intelligence, is about application of programs that are smart, that they can make decisions on our behalf, and you will find that in a lot of different places in healthcare. And machine learning is a term that's also used a lot these days, and that's really advanced statistics combined with access to a lot of computing power in the computing system that allows people to make decisions or draw conclusions from data that you could not make if you did not have those computing resources available. Another place that, again, you find computing and computer science to exist everywhere is in engineering systems, in any kinds of engineering. So here I have some pictures of a smart city. So in transportation engineering is an engineering field, but today it's infused with applications of computing. If you're building a spacecraft, obviously everything is done remotely. We don't have people operating the spacecraft in the space, so everything is programmed into it. We are not talking about autonomous cars, and there are different degree of automation that currently exists, but that's definitely in our future. And that doesn't actually finish with the cars. Just a local company around here, PACCAR, is building autonomous trucks now, so that trucks that can operate and transfer goods from city to city without having a driver actively driving it. And then finally, when you get on an airplane today, the amount of computer programs that run an airplane is mind-boggling. It's just beyond imagination to see how much of that is automated using computer science. So when you think about it, really computer science is on the intersection of what is considered to be the core computer science, and then some math and statistics. And when I say math, the math in computer science is actually different from the math that is in engineering. The foundation is the same. You still have calculus and linear algebra and statistics and probability, but that's about it. It doesn't necessarily get a lot more advanced than that. Some of the engineering degrees require more sophisticated math than computer science does. And then the interesting part is that computer science by itself is not that exciting, but computer science is a field that gets applied to a business or to a domain. So healthcare, engineering, entertainment, education, all of those are domains. And then computer science and computing combined with math when applied to a particular domain is really all about solving problems in a given domain. So if you ask me, what is computer science? Computer science is about problem solving. It's about problem solving using computers, essentially, and you have to figure out how to program the computers to solve the problems that you need to solve. So I wanted to kind of highlight a few myths that exist about computer science and kind of bust these myths. And again, if you have questions on those, you can ask them in the chat, or you can raise your hand and ask it in your voice, or we can also have some question answer session at the end. One of them is that you hear a lot that computer science is just about learning technology. Actually, when I was in high school, somebody told me, why do you want to study computers or computer engineering or computer science? You can just learn to program on your own. You don't need to have a college degree for that. So a lot of times people say computer science is just about learning the technology. It's about just learning how to work with it. And this is absolutely incorrect. Computer science is really about logic. It's about problem solving, and it's about creativity. So that's one myth that I wanted to dispel. The second one is that computer science is coding. This is something that actually started about maybe 10 years ago, and everybody started talking about coding. And coding is a tool. Coding is a language. It's a way we speak the language of computer science. But computer science is not coding. Coding and programming is just a tool, just like a telescope is a tool in astronomy. So I look at coding as a language, as a way to communicate. And computer science is way more than that. It's way more than learning how to write code in Java or C++ or writing to make an app. It's about really solving the problem using the language of code. The last one is that computer science is vocational. It's a job, you learn it, it's a vocational. And I want to say that no, computer science is actually very much foundational. And the case in point in this is that I don't know, 20, 30 years ago, probably your parents, when they were growing up, the fields that were considered at the time the computer science as a major didn't exist. Actually, when I started going to college, there was no officially computer science major. There was computer engineering and there was applied mathematics. So again, 30 years ago, the foundational sciences were math, biology, physics, chemistry. And I would argue that computer science is getting to that point. So the same way that you see this more and more in high schools and even in some college degrees now, the same way that you would have to learn what are the basics of physics or what are the basics of biology or chemistry, I think knowing the basis of computer science is important regardless of whatever it is that you are studying. So if, let's say, you want to study humanities and you don't want a career in computing at all, and you just want to go study humanities, that's great. But I hope that you have an opportunity to do a little bit of playing around so that you can understand the language of computer science, the same amount that you might know chemistry. If you are a, I don't know, sociologist, you still took a chemistry class, you took some physics class, you took some math classes. And I hope that, we can tell, this happens probably in Washington State, but not everywhere, that there is computer science education that's offered to everybody and it's required. So I really believe in this very strongly, that computer science is foundational and everybody should know just a little bit of it. Okay, so let's talk about what do computer scientists actually do. So computer scientists, a lot of times when you ask what do computer scientists do, this is what people think. You're sitting in front of a laptop all day, staring at it and writing code and programming. But let's kind of zoom out of this. So first of all, that's not always the case. You spend a lot of time, if you're working in industry as a computer scientist or a software engineer, you also spend a lot of time talking to people and designing and planning and problem solving. So it's not just all this sitting behind a computer and working. And I want to kind of highlight some of these applications here. So if you remember that graph that I had, the Venn diagram with domain expertise, computer science is about solving problems in other domains. So let's say you are also interested in sciences, you're interested in biology, you're interested in oceanography. Computer science combined with a scientific discipline can help you build underwater robots that discover what is in the ocean, that help you learn more about the nature of what is in the ocean, for example. Genomics and sequencing genomes has helped solve a lot of previously unsolved problems in understanding diseases. And that's something that would not have been possible by biologists or geneticists by themselves. The application of computer science in those fields has been able to advance the field to the degrees that you see. Computing is used to develop new drugs and pharmaceuticals, and that's another application of computing. Again, a computer scientist by themselves cannot do that. They work together with the scientists, and that goes back to dispelling that question of, oh, I'm sitting in front of a computer coding all day. No, you're talking with people in that domain and trying to learn what their problems are and try to solve their problems. And obviously, understanding the outer space and extraterrestrial phenomena, all of those without the use of computing power and learning doesn't happen. Same kind of argument. So this is if you are interested in science and you're really not sure about computer science. Here is some way that you can see how the two can emerge and can merge and can kind of lead into something that you are interested in. I can tell you that I had students who would study computer science. Sometimes they would double major, sometimes they would minor. I had one particular student I can think of that who studied computer science, had a biology minor, and decided to go to graduate school. And she is actually a computational biologist now. So she's a professor at Case Western University, and her work is more biology than computer science. I don't actually understand what she does, but she's definitely combining computing and biology in solving or understanding research problems that she's interested in working with. Sometimes you might be interested in business, and a lot of people say, I want to go study computer science because I can start my own company. I want to be an entrepreneur. I want to have a startup. guess what? When you are an entrepreneur, you are, again, you're solving a problem in the society. You're finding a gap, something that needs to be addressed, and then you build a company around that to solve that problem. And this is not my sentence. You Google this and you'll find it everywhere. Every company is now a tech company. If you think about your bank is as much a financial institution as it is a tech company. You do everything. You do all of your online banking on your phone or on a laptop. When was the last time somebody walked into a bank? So a bank is also a tech company. If you think about selling something online, that's also a tech company. If you think about education online, that the tech component is nowadays such a big part of all of the entrepreneurial kind of endeavors that every company is really a tech company. And a lot of co-founders for companies have some kind of a technology background, because that helps them connect the technology foundation to a domain problem that they are trying to solve. If you're interested in business, also businesses these days are very interested in big data analytics. Again, this is the same thing you might hear data science or machine learning. That's really about using the power of data that they have about their products, about their services, about their customers, to draw business insights from those data. So I will give you an example. A local retailer, REI, most of you have been to the store. Several years ago, we had a project with them, and they were interested in understanding how they should be using weather forecasts to decide what kind of products they should put on display as soon as you walk into a store. So whether they're showing a jacket or a tent or whatever it is they put on display, they wanted to know what they should put on the display. And they didn't want to just look at the outside and say, oh, it's 68 degrees, we should put this jacket. They wanted to look and understand, what did customers buy on days like this in the past across the country in different areas, and how can we draw insights from what they have bought in the past to predict what they would buy in the future, and based on that decide what to put into the display case depending on the weather. That's just one example. There are many different examples. So these are business decisions, and computing is used to draw business insights from the data that exists out there, and companies have a lot of data about their customers. If you're interested in healthcare, there is tons of very interesting interdisciplinary work in medical research or in health informatics or many other subdisciplines within healthcare. And a lot of these kinds of more researchy work would require advanced degrees like a master's or a PhD. But as I mentioned before, computer science is becoming really foundational. So if you go and look at, for example, a master's or PhD program in medical imaging or medical physics or biomedical engineering, they will take people with a lot of different backgrounds. And if you come in with like a computer science background, or you just need to learn the domain that you're interested in to combine that with computer science. If you come in with a biology background, then you need to learn enough computer science to combine that with, so that you can make a move. But that goes back to the fact that computer science is very much foundational these days. If you're interested in arts or storytelling or gaming or design or animation and movie production, obviously, again, computing is everywhere in all of those. There was a little video I saw that was showing how Disney, two different cartoons, completely unrelated, I can't remember which one it was, the movement of the characters was exactly the same across two different cartoons. The entire animation was was essentially a computer program, and they used the same skeleton and changed the background and the face of the character moving, and everything else was exactly identical. So again, computing and computer science sits at the core of all of these. And again, talking about some of the past students I have had students who came in and double majored in computer science and theater. And I was talking to this one particular student, and he said, I love theater. I want to work in theater, but I can't make a living with that. But the theater production also has a lot of technology requirement, and technology work that can be that needs to be done in order for a play to go live. And I want to be able to be in theater but do the technology work for theater. So he double majored in that. I have had, we have a lot of students who would come in and they wanted to double major in arts, studio arts and computer science, because they wanted to combine those into some kind of animation type of path for themselves. So you can chart, you can figure out what your passion is, and you can connect that to computer science and kind of move it in that direction using just by just having the right computer science foundation, and then taking the elective courses or a minor in college that helps you get to what you are passionate about. One other part that this actually is somewhat new to me myself. I would probably have learned about this field in the last 4 or 5 years. Is what if you're interested in social sciences? What if you're interested in humanities, in sociology or economics or something like that? There are these days applications of computer science in everything you can imagine. So modeling and simulating and analyzing social phenomena, those are all also fall within the field of computer science applied in the context of humanities and social sciences. For example, I know people who study loneliness, and they are a computational sociologist who do this kind of work. So they have studied a combination of sociology and computer science. They can understand the spread of rumors and misinformation. So you hear misinformation is a big problem these days in our society, and just understanding how these things spread. What are the factors that help rumors spread? Why some rumors spread but others do not? Those are things that can only be understood. Computer science can be applied to understand that phenomenon, but you need to also have somebody needs to have work with you that has the sociology background that's necessary to understand human behavior there. Computing is used to study happiness or social interactions and peer influences. There's tons of different kinds of research projects that happen. I actually was working with, before I left the university, I was working with a political scientist on a project on this regard. Okay, so all of those to just say there are many. Computer science is not humanities, it's not engineering, it's not healthcare, it's not biology, but it can be applied in anything that you have interest in. So there is a lot of things you can do with a basis, with a foundation in computer science. So what is it? What is computer science? So as I said, I don't like the term coding. Coding is not computer science, and computing is much more than coding. But computing, the field of computing is about hardware. So whatever is inside your computer, inside the servers, inside the devices that you use. It's about operating systems, things like Windows and Mac and Android and Linux. You've heard about those. Those are operating systems. It's about applications, all of these things that you use every day. I don't know. WhatsApp and Telegram and Zoom and Skype and Adobe PDF and Gmail, all of these are applications. So it's about those. It's about user experiences. I'm sure you've had the experience of working with an application and you just say, this really sucks. I can't really get what I want to get done. I have to click on this 5 times, or I can't find this button that should be here, or this is so unusable. That's an example of a user experience. So as a user, as a customer, that you're using that product, you have a particular experience. In the past, again, back to your parents, when many of us, when we started using computers, it was all keyboard, and then we had a mouse. And now we can interact with the computer using our voices. There are touch interactions with the computers. There is a lot of work around accessibility of computers and computing devices for people with disabilities, whether they have visual disabilities or hearing disabilities or just motion disabilities, any of those sort of things. There is a ton of interesting work that happens within the user research and user experience design that is really fascinating and really just by itself is an interdisciplinary field, because in order to design the user experience appropriately, you need to understand people. In order to understand people, you need to know psychology, and you need to know a little bit of humanities, and then you also need to know art a little bit and be able to design things. So that user experience and I'll talk about majors that kind of correspond to that in a bit, but that by itself is a really interesting, interdisciplinary and exciting area, in my opinion. That has plenty to offer. I can also tell you that at Amazon, in Alexa, where I work, user experience designers are also voice designers. There are people who design voice because it's all about voice interaction. How do you ask something without getting frustrated? I'm sure every one of us has got frustrated with Alexa or with Siri because they don't understand what you're saying, not because they can't understand us, but they can't understand our intent, or getting them to do something is really hard. So that's a voice design kind of element of this user experience design. If you think about it again, computer science is all about problem solving in every discipline, applying at different levels of this. Now, I said computing here. Note that I didn't say computer science because these lines are kind of not very clear. If you study computing and you're interested in hardware, in how things are built and designed, you are probably more interested in computer engineering than you are interested in computer science. That's more about sort of foundation and core and interactions of different pieces together. If you study computer science, you will learn about hardware. If you study computer engineering, you will learn about applications, but primarily computer engineering is more on the hardware and operating system and network level. Computer science is on the application, even though you'll learn about operating systems and hardware a little bit and user experience design. And then there are a bunch of fields that, like informatics or human computer interaction that deal with the user experience design and application side and kind of move into art a little bit. So that's kind of the overall breadth of the field of computing. Now, the next question I want to kind of talk about is who might enjoy computer science, and this goes back to that first slide that I had, that people they don't know what kind of personality you need to have. They think that you have to be a nerd to like computer science. That's absolutely not the case. So the first thing that the first type of people you might find in a computer science major are people who are technophiles. They like technology, they like to play with it, they like to break it apart. I personally was never one of those people. So you definitely don't have to be one in order to study computer science. There are plenty of them that exist, and there are plenty of people who are not technophiles who are in computer science. The other kind of misnomer is that you have to really like gaming, and that cannot be further from the truth. There are definitely gamers who become interested in computer science because they want to write their own games, but you don't have to be a gamer to become to study computer science, or to be good at it, or to be successful at it. And again, I have plenty of examples of this in front of me. I would say one important question to ask yourself is if you like to create things. Do you enjoy creating things? I think that's one of the things, one of the pleasures of writing programs that do what you intend them to do is that notion of creating something and seeing that do what it's supposed to be doing. The other thing I would say is that you want to have a good foundation in math. It's not. I'll talk about what level of math is necessary in computer science. It's not super advanced levels of math, and I'm saying this because I was a math major initially, so I took a lot more math than it was really intended. But I would say you need to be comfortable with it. You need to kind of enjoy. I enjoy the preciseness that mathematics brings, and I think that's important. More than mathematics and like computation or calculation, you really need to have that logical thinking. That's probably important. Do you like working with people? Unlike what you think, you have to communicate your ideas. You can't just sit there and just write code and be done. Once you write the code, you need to work with people. You need to work with people to not know what to write or what programs you're solving, what the problem is, what is the domain that you are trying to solve a problem in, and then what to build. That also comes from interacting with people. And then once you build it, then you still need to interact with people for them to make sure that you built the right thing and it's doing the right thing. So you do have to enjoy working with people. And again, if you are in one of those sophisticated interdisciplinary areas, you have the pleasure of working with people that are outside your field as well, that are not computer science people that you're working with. the other thing I would say is, do you like designing new products? This goes back to creating things. So, initially when you start programming and start learning computer science in college, they tell you exactly what to build. Here is a blueprint. Just build this or design this. As you become more better at what you are doing, as you advance in your discipline, you get to design new products, and I think that's really, really fascinating. And I finally would say, do you like solving complex problems in the society? Because if you do, there are plenty of problems in every aspect of the society, in medicine, in law, in business, in arts, in engineering. And you can be part of those. You can work with those people and help using the computing power to solve the problems that they are having. So if you answered yes to a couple of these questions, I think you should definitely consider this as an area to study, as a field to study. Okay, so with that, let's look at what does a computer science major look like in college. Computer science is a 4-year program. It has equivalent about a year of mathematics, so you have to take Calc 1, Calc 2. If you are in a quarter school, it's 1 year of, in both cases, whether it's a quarter school or a semester school, it's 1 year of math. So if it's a quarter school, you have 3 courses in math first year that you have to take. If you're in a semester school, you have 2 courses. It's the same amount of hours, just kind of split up differently. In addition to calculus, you also need to take linear algebra and probability and statistics and discrete math. So these are probably the only required math courses you would have to take. In terms of computer science courses, you'd have to take equivalent of a year of programming. So that was a year of math for calculus, a year of programming. That's usually 2 or 3 classes. That includes data structures. You also take algorithms. You take courses like networks that may include operating system, and then you take a course in databases. These are like core computer science courses you would be taking. And then as you enter your 3rd and 4th year, you start taking advanced topics. These might include things like artificial intelligence or machine learning or software engineering, cloud computing, robotics, embedded systems. These courses vary from university to university, depends on the research areas of the people there. You might have other courses like graphics or game design or security. I should have probably extended this list, but those are kind of advanced level courses, and you don't take all of them. You have a handful of them that you select and you take, and then so that kind of covers your computer science courses. I would say it's in computer science, it's really important to have project experiences. So if you find a university that has a university program that has a capstone program that has internship programs built into their program, they sometimes call it a co-op. Those are really important because hands-on experiences are really important for this field. And then, so that kind of covers your math, computer science, and math and computer science classes. In addition to math and computer science, you also need to take some general science courses in college. That's physics or chemistry or biology. Usually, usually they require at least 2 lab science courses. That's biology or chemistry, and I think physics is at least 1 course is required. You could take more. And then you also have, regardless of whatever major you go to, you have to take some general education classes, things like English and writing and history and philosophy. And I would, if you are if you are somebody who actually really enjoys computer science, then you are asking yourself, why do I have to take these writing classes, or why do I have to take these philosophy courses? And I would really encourage you to take those courses seriously, because those are really important. Those help your communication and soft skills. That's really, really important for your career, regardless of whatever job you decide to take. Those parts become a really fundamental part of how successful you are. Especially as you advance in your career, you write more and present more than you actually do programming or solve those kinds of problems. So those are important courses. Don't ignore them. Just from this is the same as the previous slide, but I just kind of want to say that math and calculus, programming and data structures, algorithm and networks, those are like bachelor level courses. as you start moving into more advanced topic and interdisciplinary areas, you're moving into your last year of undergraduate, or if you want to do something that is very sophisticated, super interdisciplinary, then you need to probably complete a master's degree. You don't usually need a PhD for working in industry, but if you might be interested in doing research, or if you are interested in becoming an academic and becoming a professor, then getting a PhD is something that you probably need to have. So that's in terms of courses and the type of topics that you study. I know I'm kind of going really fast. This presentation is also available afterward. You can watch it online again. But I want to spend maybe a few minutes and talk about the different kinds of jobs in the tech industry. The most common one that you hear about is being a software engineer or a programmer. I think you also might hear software developer. Those are all pretty much the same thing. But there are plenty of other jobs that are also available for the field of computing, and you can get those with computer science degree. You can also get some of these with other degrees. But again, this becomes somewhat of an interdisciplinary kind of thing. So one is that user experience designer that I mentioned, in terms of designing the user, understanding what the users, who your users are, what their needs are, what their requirements are, and then building mechanisms for them to interact with the system that you have in a way that's easy and accessible and smooth and enjoyable. So that's the user experience design. There are also user experience researchers. Their job is really to just understand what people's preferences are, what their interests are, and then help the user experience designers design those. So those two work kind of intersect with each other a little bit. But I would say the researcher is less of a designer, less of a tech person, and more of a humanities and social sciences and understanding and psychologist type of person. If you get a master's or especially a PhD, you can become a research scientist. These are people who do research work. There is the field of computing is moving so fast that you definitely need scientists to work along with engineers to solve problems. I'll give you an example of this. My team has about 20 people in it, and like I said, our job is to make sure Alexa doesn't that responds appropriately to in some situations where the response might be inappropriate. And our team has about 6 or 7 scientists. So these are researchers. They are trying to solve problems that haven't been solved before. We have something like 8 or 9 software engineers. They are building products. And then the rest of the people that we have are people who are product managers and program managers and managers that are kind of business intelligence engineers that are understanding the business impact of what you're doing. So teams usually are combined of different types of people. So research scientists or science work most of the time requires a master's or PhD degree, but there's plenty of work that's related in that area. There is a few different kind of positions for people who like to work with data, math and data. So data scientists, business intelligence engineers. These are people who work with essentially understanding trying to understand the data that comes from the products that are being built. If you're interested in security and you hear about attacks or the system has been hacked or your credit card was stolen, there are security engineers whose job is to make sure the applications and the systems are secure so that nobody can attack them. Web developers are kind of a branch of software developers, software engineers. They build websites, and website development has evolved quite a bit in the last 10 to 15 years. But web developers, basically, it's a subset, it's a layer of software engineering. It's just mostly building applications for the web, not the background, not the databases, not the internal systems there. Quality assurance engineers and software testers, their job is to make sure that they can test the software, that the software does what it's supposed to be doing. So they work very closely with software engineers. Sometimes the jobs are actually intertwined, and you might have software engineer that does the testing, or they might be different roles. In industry, if you put a bunch of software engineers together and tell them to solve problems, they need direction. And program and product managers are people who give them directions. They give them a vision of what needs to be built, and kind of give them the recipe, and then the software engineers figure out what to build. So that's their job. And the program manager makes sure everybody is talking appropriately with everybody else, and that the project is on track and it's making progress as promised. There are system and application analysts. They play different roles in different settings, but they don't do programming themselves. They work with programmers and all of these other team members to make sure that they are making progress on the goals. And then if you are, in a like I mentioned before, a lot of if you're interested in entrepreneurship, especially for small companies, CEOs, CTOs, a lot of them have a tech background. Even in large companies, they do sometimes, but you can definitely go up to that level, and if that's something that you're interested in. So this is a little bit of an overview. Again, my goal is to say you don't have to become a software engineer if you study in the field of computing. There are a lot of different opportunities that might be available to you. There are also different kinds of degree programs. And again, everybody hears about computer science, but I looked up these lists just from UW and Seattle U. Actually, if you go outside and look at other universities, they might have other kind of interesting programs that are available as well. The most common one is computer science. There is also computer science with data science, or with business specialization, or with math specialization. I can talk about what those are, but you can think of those as being a computer science degree where your elective courses are more in math, or in business, or in machine learning type of classes. Computer engineering also is a computing field, as I mentioned, that's more closely related to hardware side of things. There's electrical and computer engineering, which again overlaps with computer engineering and computer science, is more of an engineering discipline. There's data science as a standalone field that's relatively new. Most of the times these days, still to be a data scientist, you need to have a master's degree. It's still pretty advanced field. But if you really like math, then data science has more math than the computer science does. It requires more math foundation there. There are 2 or 3 degrees that are listed here that are on the user experience design side. So human-centered design and engineering, informatics, and human-computer interactions. These are degree programs that are specifically combining psychology and design and art and computing together. They're lighter in terms of technical foundation than a computer science or computer engineering is. Cybersecurity or something related to that is computer science programs or computing programs that are specialized towards security and security applications. And then something that has started emerging over the last few years is this is called different things at different universities, but they're called computer science plus X. As you probably mentioned, as you saw in the presentation that I gave earlier, computer science overlap or can be applied to a lot of different domains and disciplines. And there are university programs that are combining those. So you can get a degree that's computer science plus physics, or a computer science plus biology, or computer science plus business, or computer science plus theater. So there are some universities out there that actually let you design what that X is. Sometimes that X is a predefined set of majors that you can combine with computer science. Sometimes they allow you to pick something that you are interested in. I would say at Seattle U, they have a Bachelor of Science in Computer Science program, but then they also have a Bachelor of Arts in Computer Science program, which is a light version of a computer science degree. If you don't want to get a software development job and you want to get something else in a particular discipline, that Bachelor of Arts degree is a perfect platform to combine that with some other discipline and graduate still in 4 years and get 2 degrees and then be able to apply your computer science degree in that other discipline. So that's something to consider if you're not completely sure computer science is the right degree for you, you kind of like it, and you also like some other areas. Also remember, you can minor in computer science or some computing related field. You can minor in data science. That's something to consider if you are you're really sure you're hardcore biology, you're interested in biology, or you may be interested in pre-med, you can still minor in computer science. This goes back to computing being a foundational course and kind of like treating it like math. That way you have that foundation so you can apply it and use it in your career later on. The other thing is, again, if you are going to college with a lot of AP credit or with some running start credits, you can sometimes graduate in 4 years and easily double major. You can double major even if you don't take AP credit. If you don't bring AP credits, you can still double major and graduate in 4 years, but the majors need to have some overlap. So let's say you decide you want to double major in math and computer science, you can do that and still graduate in 4 years. Or physics and computer science, you might be able to do that. But if you want to double major in computer science and history, there may not be as much overlap. So having some credit from Running Start or from AP helps with that. One last thing I wanted to say is that a lot of people, you don't need a master's degree to work in as a computer scientist in industry. Some people getting a master's degree is helpful because it lets you grow faster. And there are definitely many programs out there that let you combine your bachelor's and master's degree. Usually bachelor's is 4 years, master's is 2 years. So if you get a bachelor's degree and then decide you want to get a master's degree, you would have to go to school for 6 years. But there are many programs out there that let you combine the two and graduate in 5 years and get a bachelor's and master's degree. And then if you bring in your Running Start credit or your AP credit, you might be able to actually get that master's degree in 4 years. So you could cut that by 1 year and still get a master's degree and graduate in 4 years. So those are some things to consider if you're able to take a bunch of college credits from high school into college. Couple last things I want to say. I really sincerely believe in this. Every 21st century student should have a chance to learn about algorithms and how to make applications, and they need to understand how internet works. So if I ask you today, what is photosynthesis? A lot of you know it. Everybody knows it. And if I ask what is H2O, everybody knows a little bit of chemistry there. Everybody knows a little bit of biology. So these are all of the things that I think every 21st century high school student should also learn. And if you are still in high school and you don't know what these are, I encourage you to take a course. You don't have to become a computer science major, but you need to be able to think using computational concepts. And I think that's really critical given where the 21st century is taking us these days. Couple of last things. Why study computer science? Computing is part of everything that we do these days. There are many opportunities for innovation and creativity. It's a growing field with a lot of rewarding careers, with amazing job prospects. You can make a positive difference in the world, and it's fun, it's challenging, it's interesting, and it definitely is not boring. So those are kind of my pitch. And lastly, here is a bunch of statistics from the US Bureau of Labor and Statistics that's showing the job projections for 2020 to 2030. So if you're in high school right now, this applies to you. And if you look at, these are just 4 of the major kind of positions that they call out: software developers, web designers, information security analysts, and computer research scientists. And these are the median income, median salary for 2020 in these different fields. As you can see, they are very well paying jobs, and the job outlook for 2020 for the next 10 years, 9 years is also, in all of these cases, they are growing faster than average job growth, or they're growing much faster than average job growth. So there is definitely a lot of demands for these type of positions in industry. With that, I am done with my presentation, and I'm more than happy to take any questions.
Wonderful. Thank you so much, Roshanakjan. It was great. It was a very good presentation, and I think I was right saying that you are the best person to deliver this talk. I'm sure that everybody enjoyed and learned a lot. So before people start asking questions, I have a favor to ask. So I created a survey for people to fill out. It's just mainly about getting basically feedback from you about what you like about this presentation, and also your backgrounds, whether you're a high school student or whether you're parents, and also about the other programs that you would like us to offer. What other university majors you would like us to introduce, or any other program in general that you would like us to offer as part of the youth group. So please take some time to fill out this survey. That would help us a lot. And please feel free to ask your questions. Roshan, I think, will be here in the next few minutes to answer your questions.
I just want to reiterate what Afshin just said. We really want to know what should be the next program. If you tell us what you want to hear about, we will make that happen. We'll bring an expert that can speak to that major. It won't be me, I promise. So please just do the survey so that we can learn from what you're interested in.
Yeah.
Now, any questions? You can type in your questions, or you can come on video and ask, or just
also let me just turn off